into chemical bonds um, that allows almost everything in the ecosystem to live. Now, the other end of this is ecosystem respiration. And what we're talking about is really when all organisms, plants, animals, fungi, bacteria, everything, when it's using energy, is essentially breaking down carbon bonds, taking that energy from it, and releasing carbon dioxide into the atmosphere. Collectively, we call this ecosystem respiration. Most of that is going to be from plants and decomposers. Animals, insects play a bit of a role, but mostly it's plants and decomposing microorganisms. And the difference between those two, the carbon in and the carbon out, is our net ecosystem production, and that's our carbon sequestration. So if we have more carbon coming in than is going out, we're sequestering carbon. If we have more carbon going out than is coming in, we're releasing carbon from the system. So this figure represents how we used to think about how forest productivity would change with forest age. And it's still the model that a lot of foresters adhere to, even though the last 15 years or so has really upended this understanding and model. But what we see here is net ecosystem productivity or production, NEP, and these different phases of forest development. And very early, when a forest is reset through a major disturbance like a tornado or heavy logging, for a short period of time, it's a net emitter. So the carbon coming out is more than the carbon coming in. But then that NEP increases. So it's packing in progressively more and more carbon, and then it peaks at a certain point and then declines. And it used to be thought that at a certain point, and generally where we would think about forests as being old growth, that gross primary production and respiration essentially canceled each other out. That the decomposition and respiration were essentially equal to the amount of carbon coming into the system, and so that old forests essentially did not sequester any more carbon. However, we now know that for the most part, that's not actually the case, and that what actually happens is that NEP decreases and tends to plateau, but it plateaus in the positive. So older forests tend to continue to sequester carbon at a lower rate, but that total carbon they've sequestered continues to increase over time. So carbon still accumulates in old growth forests. On the left is a figure from 2008 that was a really important paper, I think. And what this figure shows is the authors looked at old growth forests from around the globe. And in this figure, the green dots are temperate deciduous forests. And the this is temperate, forest, doesn't include tropical. And the orange are, I think, boreal forests. So really looking at the green dots here. But what they found was when they look at actual measurements of old growth forests and temperate forests around the world was that old growth forests continue to increase the amount of carbon that they're packing in continually. And that really helped upend assumptions about old growth forests being what they would term decadent. On the right is a figure from 2023 on net primary productivity in southern forest types. Now, net primary productivity, NPP, it's similar to NEP. What it is it's the carbon coming in to the plants minus the respiration of the plants. So it doesn't include decomposition in the system. It's just the respiration of the plant. So similar concept, though. The numbers will be a little bit different. But what we see here in these different forest types in the South is that NPP and that productivity peaks around 20 to 40 years for most of these forest types. And then it decreases and tends to plateau, but it's plateauing in the positive. So these older forests, they're not sequestering as much carbon over time as a younger forest, but they're still in the positive by quite a lot. So why is that? So need to digress a little bit into some of the characteristics of old growth forests, which really can be an entire presentation entirely on its own. But we'll go over a little bit of this. So on the left, the figure is a combination of figures that show what we think of as the stages of stand development. And so the idea is that we start with a major disturbance that removes or kills a majority of trees in a piece of forest. So tornado, clear cutting, something like that. And we end up with what's called stand initiation. And so that's when all these new things sprout up. And we pretty quickly move into what's called stem exclusion. And during stem exclusion, what we have is a large number of trees, very densely packed, growing pretty quickly. And what happens is there's competition among those trees for resources, for light and moisture, particularly. And through competition, some of those trees die. We consider density dependent competition or self-thinning. But what happens over that period of time is that some of the trees will lose and they'll die. And the other trees that live are able to take up that space and those resources. So over time, through stem exclusion, our number of trees goes down and the size of the trees go up. Eventually, we reach what's called understory reinitiation or demographic transition. And this really typifies what sort of a typical mature second growth forest that most of you have probably hiked in. And so that's a forest where we're going to have pretty high canopy, pretty large trees, but that forest canopy is going to be pretty even. The most of the trees in the canopy are going to be about the same height. That canopy is going to be pretty closed in structure, and it's going to be mostly still even age, but you'll start having some younger cohorts, younger trees in that understory. Eventually, though, we move into the old growth, or what's also called the old multi-age phase of stand development. And what's going on here is that small and intermediate scale disturbance. So events that take out individual or scattered or small pockets of trees lead to changes in forest structure. So that creates, for example, gaps in the forest where we might have little pockets of young trees that come up, and the trees adjacent to those will have more light and resources and grow larger. But then we'll have areas that still have more dense canopy. It just becomes more structurally complex. So we'll have big dominant trees, layers of co-dominant trees, just a lot of structural complexity. And that really is in many respects, defines old growth forests in our region. This image on the right is from the cover of a great book, Old Growth Forests, Function, Fate, and Value. And what I like about this is I think really illustrates on the left, the stem exclusion, where you see these really small, tight canopies, demographic transition, where you see a lot of larger canopies, but are all pretty much at the same level. You don't see a lot of variety in size or pockets and space in them. And then on the right, you see this really complex, more variable looking canopy where you see kind of gaps and shadows and different sized crowns. And so that complexity becomes really important when we think about how that ability to sequester carbon is maintained in these older forests. So I don't want you to get lost in this figure. It's from Kurtz and Gao 2018. I want to read the text of the figure though, because I think it really expresses this very well. Moderate severity disturbance may sustain net ecosystem production at higher than expected rates in aging forests by the introduction of physical and biological complexity as the leaf area recovers, which in turn may result in the redistribution of growth limiting resources and enhance resource use efficiency. Canopies made more complex and physiologically efficient through periodic moderate disturbance may sustain NEP later into ecosystem development. So this goes directly contrary to some of the dominant assumptions in forest management. Um, we know the science has evolved. Unfortunately, a lot of the narratives that we see in management have not kept up with where the science is. So we even still see in certain projects in the Forest Service recently arguments that these older forests are not actively sequestering carbon. And that's just not really the case. So in terms of management and timber harvest, we see some of these same processes. I would say something analogous to it. So this is some data that I adapted from a paper from 2009 from research at the Furnow Experimental Forest in West Virginia. So very similar forest to our forests in eastern Kentucky. Um, so when we look at this figure, don't worry about the absolute numbers. This is expressed in average annual grams of carbon per meter squared. But what they did was they looked at four different forests. Um, First was a reference forest that they didn't do anything to. There was another one that they clear cut. There was one that they did a diameter limit harvest or 5 harvests. So a diameter limit is where periodically you go and you cut every tree over a certain size. And then a single tree selection harvest with 6 harvests over that period of time. And the study started, well, the measurement started about 10 years before that clear cutting. And what they found was that over this period of time, the average uh, ecosystem productivity was actually lowest in the reference forest that they didn't do anything with. And that the diameter limit and single tree selection harvest had substantially more average biomass accrual than the clear cut or the reference forest. And they attribute that largely to with the clear-cut forest, you're having a secondary forest that then loses most of its capacity to sequester carbon. And it ramps back up, but you have a good period of time where it's not. So you have emissions, you have slower growth, and it takes time to catch up. These thinnings that they did, they found they stimulate periods of growth and accelerated growth, even with the loss of some trees through those harvests. And they attribute that to basically increased resources for those remaining trees, not too dissimilar from what we saw with old growth forest in terms of having that structural heterogeneity. You're losing some trees, but you're retaining a lot of trees. And that change in the distribution of resources actually allows for more carbon accrual than in many cases of forest that just really hasn't had any disturbance. So the other part of carbon and forest management is emissions from logging. This figure is from a report done by Oregon Wild. The data were from a couple of different papers from around the continent. Um, I was never able to quite figure out if their figures came specifically from Oregon data or was pooled from the whole continent, and I haven't gotten to work through it. So don't worry about the specific numbers here, but I want you to be able to think about sort of these pools of carbon. So on the left, we see live tree. So you assume that's your live tree biomass. That's the carbon in the trees standing. When you log, you take the saw logs out of the forest and you leave the logging residue, the slash, the canopy, the branches. And that's important for returning nutrients to the soil. But what happens is you're leaving a lot of that at one time, and over several years to a couple decades, all that's going to be decomposing at once. And so that decomposition puts emissions out over that period of time all at once instead of gradually as it would in a natural system. And then at the mill, you have mill residue. So you have sawdust, bark, um, leftovers, all the stuff that's not going into the wood products. There is, work in the wood products industry to, utilize a lot of those materials, but these just get into some of the complexities when we talk about where the carbon's going. And then there's the carbon involved in transportation. It takes a lot of fuel to get logs out of the forest to the mill, process everything. And so then the net is not all that much. And this is all really important too, because again, folks in industry and even the Forest Service will often make the argument that logging is important for sequestering carbon because we take that wood and we put it in long-lived wood products that are essentially sequestered, and then we stimulate more rapid growth in younger forests because young forests grow quicker than old forests. And that's a narrative that's simple, They say it a lot, but it doesn't quite hold true. So another aspect of this that's not in that figure is losses from soil carbon. Soil carbon is some of our most stable and long-lived carbon, but increasing sunlight on the soil increases soil respiration, as does disturbing the soil increases soil respiration. So, we see a lot of soil disturbance with logging in our area. Sorry, that first one, that's from the Bear Creek sale in the South Redbird project on the Boone. This is just last year. This is from the Pine Creek project near Pine Island Double Falls. Just an enormous amount of slash on the ground. Some areas it's 5, 6 feet deep. You can't get across it. It's a lot of material. This video clip, and it might be a little choppy through the Zoom, shows a shelter wood cut in the Redbird district and a landslide that we documented there. And so you can see there's a lot of soil disturbance from all these skid roads back and forth to mass wasting soil movement from landslides, as well as the soil exposure to the higher light levels of sunlight and warmth. Another one from the Bear Creek sale. This is another skid road. This is not a road. This is a skid trail, and pretty typical. This was just forest with no road grade in it before they did this. Again, pretty typical. It's a lot of tore up ground. So, North American forest carbon at a glance. So, on the left is a figure of carbon density of North American forest. And what you'll see is that our most carbon dense forests are up in the Pacific Northwest. So, a lot of these are temperate rainforests. And a lot of that area of temperate rainforest actually sequesters more carbon than tropical rainforests. And that's because their gross primary productivity may be lower than tropical rainforests. However, because the temperatures are lower, ecosystem respiration is lower. There's less decomposition. And so that net carbon sequestration is even greater in those forests. But then the next most carbon-rich forest region is the Appalachian region, which you can really see the big swath over here. And based on various Forest Service data, U.S. forests removed an average of 267 teragrams or million metric tons of carbon annually from the atmosphere from 2000 to 2014. Emissions from timber harvests are estimated to have released 89 teragrams of carbon per year back into the atmosphere. And in 2021, U.S. forests offset more than 12.4% of total U.S. greenhouse gas emissions. These forests are doing a lot of work for us. Now, the other really important component of this is forest disturbance. So I'm mostly talking about natural disturbance and harvest. The thing we haven't talked about really is fire. When you look out west, fire is a very significant forest disturbance type, and fire does release carbon dioxide back into the atmosphere. It's another pathway or mechanism that didn't really address in sort of the NEP model. When you look in the east, you see most of the forest disturbance is harvest. That's the primary forest disturbance in the east. And you'll see there's a lot of fire in the central Appalachian region. So you'll see over here, all this red in West Virginia, a bit of Kentucky is fire. But when you actually dig into the data for Kentucky, our carbon emissions from fire are extremely low. Part of that is the amount of fire we have, and part of that is actually the types of fire we have. We don't tend to have big crown fires that consume a lot of wood. Most of our fires burn up leaves and twigs, which release some carbon, but really not an enormous amount. So Kentucky forest carbon estimates. I took data that was from the Forest Inventory and Analysis. It's a National Forest Service data set. And this was published in an appendix in Walters et al. 2023, and I was able to take those data, make some figures. So on the left, we see estimates of total biomass in Kentucky forests from 1990 to 2022, and it's broken up into the different pools of carbon. And so what we see here is the main increase is in above ground biomass. That's our trees, essentially. And most of the other pools are considered to be pretty stable. They estimate a slight increase in below ground biomass, but you can also see that the bulk of the biomass in the forest is soil or mineral carbon, and that's really stable, long-lived carbon. That's why protecting soils is really very important. But it's been increasing over time and continues to increase. Now, on the right, we see the net influx of carbon into our forests in Kentucky from 1990 to 2021. And what you see here is that it's decreasing over time. And you see that the orange is that above ground biomass, and it's decreasing. Well, but it's still positive. Why is it decreasing? Well, I think that's largely because of age demographics of our forests. So I actually have two different types of data in this figure. So it's a little bit apples and oranges, but I'll walk you through it. The blue bars in here are represent acres of forest in different age classes from FIA or Forest Inventory Analysis data. Again, it adapted from a recent paper. But what we see is that the vast majority of Kentucky's forests are estimated to be between 40 and 79 years old. And when we think about the productivity in our forests, they tend to maximize around 20 to 40 years. And so we see these forests moving out of that peak productivity, but they're still sequestering a lot of carbon. So as these forests get older, the amount of carbon they'll be sequestering in total increases, but the rate is going to decrease. Now, the other thing I want to point out here is the yellow bars are Daniel Boone National Forest. Now, that data is from Forest Service inventories of the national forest. It's more granular. And so the numbers don't quite align, but they're both expressed in acres of forest. And what I want to point out here is when you look towards these older ages, um, essentially, almost all of our older forests over 100 years old and old growth forest is in the Daniel Boone National Forest. Now, this here, the 100 to 119 and this 120 plus, technically impossible, right? It says there's more acres in the Daniel Boone National Forest than there are in Kentucky, and that doesn't make sense. But it just has to do with statistics, sampling, the data sets. But really what we're seeing here, and I think what this represents, is that majority of our old and old growth forests are on our public lands. And we can't rely on having old and mature and old growth forests on private land. They're just under too many pressures. So we're going to dig into the Daniel Boone National Forest a little bit and talk about carbon on the Boone, where it is, where it's going. So in general terms, we've got this big the bulk of our age classes on the Boone are 81 to 120 years old, and those forests are what we would largely consider to be mature. Once we get over that, we start getting into what we consider as old growth conditions. Now, most figures that you'll see published from the Forest Service on the Boone will truncate a figure like this and cap it at around 120, 140, sometimes even 70 years old, and kind of lump all that in together to make the argument that most of the forest, on the Boone is really old and we don't have enough young forest. But for this figure, I extended it out to really what we found as sort of the maximum ages that we've documented in Kentucky forests. We have forests where we document 350-year-old trees. And so if you look at it, if you stretch out the graph that way, it looks very, very different. Now, let's think about this in terms of productivity and carbon. This line, this figure, this is generalized, but the idea is that these 20 to 40-year-old stands here, this is about where our peak productivity is going to be. This is sort of the heyday of logging in the 80s and 90s. And then that net productivity is going to taper off, but stay positive. The carbon accumulation will go up and plateau, but still keep going up a bit. And then down here we have carbon emissions. So the idea is, creating young forests through management. There's a carbon cost to that. So now I'm going to pivot it into old growth planning on the Daniel Boone. And one of the things I want to point out first, though, is that sometimes people think that old growth forests are all giant old trees, and certainly big trees are an important component of old growth and thinking about old growth. This is the national champion red hickory that we documented in the South Redbird Project and the Little Flat Creek sale that some of you are probably familiar with. It's from when we climbed it and measured it a couple years ago. This is up there. Massive tree and in a very productive forest, a forest that is packing in a lot of carbon. This is the new state champion northern red oak that we recently documented in the Jellicoe Project area down in McCreary County. We documented this just a couple months ago, and it was just confirmed by the Kentucky Division of Forestry. It's in a unit plan for clear cutting. Big tree. This is a forest that's not considered old growth, though I think it probably should be. It's in the Caney Knob sale in the South Redbird Project. This is this tree I was standing at the base of is a yellow buckeye. Another example of a really productive forest. So these are forests that are really sequestering a lot of carbon. This has probably been cut by now. We haven't gotten to go back yet.
Jim, can I interrupt you for a question that's relevant?
Yep.
We have Devin Rogers in the chat is asking, is the age of a given stand of forest based on its oldest trees, or is it averaged across age class? Does that become complicated in situations where areas were logged but some trees were spared?
Yes. So the Forest Service applies very inconsistent and problematic methods for accounting for age. And so the main system that they use um, for these stand inventories, they typically so the forest is divided up into these administrative stands, and they tend to be about 20 to 50 acres ish. And they'll go in and periodically inventory them, usually when they're planning on doing a timber project. And they'll set up plots, and they'll usually have about one plot per every 10 to 20 acres. And then we'll find that they'll often core anywhere from 1 to 3 trees across the entire stand, and then use that to ascribe an age to the stand. Now they apply what they call they list as what they call it consider as the representative stand age. Sometimes that aligns with the tree core data that they collected from anywhere really from 0 to 3 trees. So sometimes it aligns with those numbers. Sometimes you see them averaging those numbers. Sometimes you see them putting an age that bears no resemblance to any of those numbers. Um, and the protocols are supposed to identify trees specifically that they assume to be representative of the stand age. And when you actually read the protocols that they're using, the characteristics of the trees they're supposed to target for sampling are structurally basically avoiding what we know old growth trees to tend to look like. So they're targeting trees that generally look younger. Now, with old growth, and this gets into a lot of detail, but I know Devin, so I'm going to give him a little more answer. So the there are rules. There are rules that aren't really they don't adhere to that where for old growth inventories, they are supposed to base the age of the stand on the oldest age class present. So administratively, and we'll get into this actually a bit in this next section, stands are considered old growth administratively on the Daniel Boone if they are of a minimum age relative to the forest community type. And so that's usually anywhere from 120 to 140 years old, depending on the forest community type. And if it's younger than that, then they don't have to assess it for its old growth condition before approving cutting it. So they will core trees and they will say, well, it's younger than that. We don't have to consider it for old growth. However, we found multiple stands where when we actually look at the data, there may be trees in there that are 150, 200, even 300 years old in the data that they kind of ignore, or they average them in with younger trees and kind of disappear it so that the stand age that they put in their database is younger than that threshold for considering as old growth. So they never even list it as a consideration for old growth. We've also seen trees where they've uh, cored them so they're much younger than they are because we've checked up on that. And then another thing that happens is a lot of these stands are heterogeneous, meaning that sometimes you'll have a stand where maybe the lower half was cut, say, in like 1930 or 1960, but the upper part of the slope maybe wasn't. It's really two stands, but they sample maybe one tree from one section and two from the other, and they just use the younger ages and say it's younger or average it. And then the other thing that happens, and this is kind of, I think, the more interesting complex forest, is a forest that might have had some timber harvest, maybe say after chestnut blight in the 30s, but where many of the trees were retained. And that forest has really developed since then, and it has a lot of old growth character and in an older age class. It gets really complex, and unfortunately, there's not a lot of standardization for that the Forest Service has to follow. And so a lot of this falls victim to bad faith and poor methodology. And so when we've gone out and identified forests that are old growth, hoping to contribute, the Forest Service just says we're wrong, and that's that. We can get more into that at the end. It gets there's a lot. I could go on for hours about this one. So in this picture here, though, this kind of exemplifies it. So this is an old growth dry oak forest in the Elisha Creek watershed. It's approved for logging in the South Red River Project. It's part of our lawsuit there. And we did a fair amount of coring with Dr. Justin Maxwell of Indiana University, who's pictured there as part of some of his dendroclimatology research. And they said the stand was not old growth. It wasn't even considered to be evaluated for old growth because they said it was too young. But the upper part of the ridge, a lot of these trees are well over 200, some over 300 years old. And so this is an example of a dry old growth forest. So these gnarly trees are really old, not a productive forest at all. I mean, the tree rings are really tight. They grow very slowly. Here's another one from another part of the Elisha Creek watershed. I mean, it's just gorgeous. These are my favorite forests. I love big trees, but man, these like stunted, gnarly dry forests they're just gorgeous. And these are a lot of the forests we're really trying to save because a lot of these foresters, they look at them and they just say it's, junk forest. So to get in and talk about old growth planning broadly on the Boone, and this is something that we really need to collectively do more work on and to think long term about. And we're going to be talking about first this figure on the left. And when I want to talk about the old growth compatible versus not old growth compatible, is that the National Forest, the Daniel Boone, is divided up into different management prescription areas. Some of those are defined geographically, some of those are defined by the type of area that it is. Some of those areas, logging's not allowed. A lot of those areas, logging is allowed, but in a very limited fashion. And I consider most of those to be generally compatible with old growth management. And then there's areas where that are just not old growth compatible, and those are where logging is really emphasized. And so the forest plan estimates that nearly half of the forest is essentially old growth compatible. And the Forest Service cites this frequently when we're talking about the need to protect old forests and manage for old forests in project areas where they're planning on logging. They often say, well, look, about half of the forest is de facto old growth and isn't going to be able to be logged. Now, that's problematic in a couple ways. First of which is that a lot of those areas, and we'll get into this, technically can be logged, but it's just more limited. But the bigger problem is that their data are bad. This is outdated. Our forest plan was adopted in 2004, so the data they used are more than 2 decades old. And the data, the geographic data we have to do these analyses is so much more sophisticated and detailed than it was 20, 25 years ago. So I've been reanalyzing some of the forest plan with more contemporary data. And so this image here kind of exemplifies one of the issues. So um, a major chunk of the forest that they say is essentially off limits to logging, or what's called the riparian prescription area. And the riparian prescription area, they are actually allowed to log. They're just not supposed to log as much. But I think broadly it could be considered old growth compatible. Now, what's considered a riparian area under the forest plan is based on whether or not it's in the 100-year floodplain or a distance from the permanent stream channel. The forest plan, what you see in the pink here is an old data set that's the data, basically the data that they use to estimate how much of the forest would be protected in the riparian prescription areas. It's very coarse data. The purple that you see is data that I worked up using current FEMA data for the 100-year floodplain, which is under different terminology now, and doing distance buffers on the streams from the USGS National Hydrology data set. And so what you see in this image is that these purple lines are actually the areas that meet the definitions and the criteria for the riparian prescription area. But the pink are the areas that the Forest Service estimated in the forest plan are within the riparian prescription area and are therefore protected, but they're not. You can see there's a big difference there. We see a similar thing with cliff line. So the other big chunk of quote unquote protected forest in the Boone is our cliff line, which we have a tremendous amount of. So under the forest plan, the Forest Service isn't allowed to log 100 feet above a cliff line or 200 feet and 200 feet below a cliff line. And there's certain definitions about how to define a cliff line. In the forest plan, they estimated there to be an enormous amount. Now, when you actually start looking at it, though, it's a lot less. And I haven't finished this analysis, so my numbers aren't complete yet. But in this image, what you see is a section from Camp Wildcat area in northern Laurel County. And the orange squiggles are those 300-foot buffers that the Forest Service thought to be cliff line. But they were using very old geographic data where they just looked at stuff that was really steep and drew lines over and thought that might be cliff line. But much of it, and in some areas, most or even all of it actually isn't cliff line. And we can do those analysis now with modern LiDAR data sets, which are really high resolution, and you can really pick this stuff out. So in here, this is where I've been reworking stuff. The orange is stuff that they thought was cliff line that's in their data set. The orange is stuff where I've looked at and it appears to actually be cliff line. So you can see there's a big mismatch here, and especially in some parts of the forest. For example, in the Redbird district, they said there'd be a lot of cliff line, and you actually start looking at it, there's almost none. So they say, hey, a lot of that district is actually old growth or going to be treated that way because of cliff line, and it's actually not. It's just really steep, so they can log the heck out of it. So I've been reworking those data. And so when we start looking at that, right now, it looks more like you've got barely a third of it in old growth compatible management. And I've only reworked a small portion of that cliffline data. I suspect it's going to be decreased by another 30 to 50,000 acres by the time this is fully reanalyzed. So even under their own terms, if you used better and contemporary data, you would see a very, very different picture rather than this half the forest is off limits to logging. It's a third, probably more likely a quarter of the forest is actually what I would consider old growth compatible management. But there's another issue here, which is that what are we talking about with old growth? So there's areas of old trees, places where old trees get to be, But then there's also thinking about functional blocks of old growth forest. So most of this quote unquote protected area on the Daniel Boone is these linear features. So most of these riparian corridors are going to be about 200 feet wide. Most of these cliffline corridors are going to be about 300 feet wide. They're cool areas, but they're not functional chunks of forest. So this image shows an overlay of the uh, old growth compatible management types over the Dana Boone and the Horse Lick and War Fork watersheds in Jackson County. So the big blob down here on the left is a designated old growth management area. Up on the right, this is the up on the right, this is the War Fork corridor. We've got some cliff line here and a lot of riparian areas. So you can see you have all these areas distributed, but they don't really make for much in the way of blocks of old growth forest. So if we look at the forest plan and we actually take out these riparian and cliffline corridors in terms of thinking about old growth forest, then we end up with only about 70,000 acres, or about 10%, a little under 10% of the Daniel Boone is actually being compatible with managing for blocks of old growth forests. But in the forest plan, logging is actually prohibited on about 3% of the forest. So we've got about 15,300 acres of designated old growth, 658 acres in research natural areas, and a little over 17,000 in designated wilderness. Not a lot. So it's a very different picture than the Forest Service claims that half the Boone is effectively off limits from logging, and therefore they don't really have to think about managing for old growth when they analyze large project areas. So what does this look like across the forest? So what we see here, all the green is the Daniel Boone National Forest. And all the red is this aggregate of the different prescription areas that really seem compatible with old growth management. This is what it looks like when you take out the riparian and cliffline corridors. And we can zoom in on a couple areas. This is the Redbird District. Again, we have litigation here, old growth being one of the issues. And what you see here is you have this is the Big Double designated old growth, and then you have part of the Elisha Creek proposed research natural area over here, which actually doesn't include much of the old growth in that watershed. The rest of it is these riparian areas. The forest plan actually has this southern area full of cliffline, but those data are just wrong. It's just steep areas. And so as the Forest Service has, proposed enormous amounts, well, approved enormous amounts of logging across here, they repeatedly argued and rebuffed our concerns about managing for blocks of old growth forest by saying, hey, we have a designated old growth management area, and a lot of this is essentially off limits from logging anyway. And it's really just not the case. This is an area that probably more folks are familiar with, the Red River Gorge and Cave Run areas. So down the bottom here, you see the Red River Gorge geological area and Clifty Wilderness. It's one of our probably our biggest protected chunk. A lot of cliff line. Then up near Cave Run Lake, you've got two designated old growth areas. But a lot of the older forests we have actually aren't even in those areas. So in this image now, the yellow blocks are forests that are over 125 years old based on Forest Service data. And so you can see those don't necessarily align with areas that are protected or even nominally protected through these different prescription areas. Similarly, this is in the Northern Stearns District. So up on the right here, this is the upper reaches of Beaver Creek Wilderness. Down here, this is the Natural Arch Scenic Area. And this is a designated old growth area on Straight Creek. And then the rest of this is cliffline and riparian stuff that I haven't fully reanalyzed. When we look at some of the stand ages, again, the yellow here is stands inventory to be over 125 years old. And one thing I want to point out, this area outlined in black is the Stearns rough grouse emphasis area, which they're planning a major logging project. And the emphasis here is young forest, including cutting a lot of this older forest in here. So again, a lot of the older forest is not actually protected under these management prescriptions. So I know we got sort of two different but overlapping issues that I brought up, and these big questions that I think really deserve more discussion. And one is, how do we plan for long-term recruitment and sustaining old growth forests on the Daniel Boone? Um, it's not necessary that even all of our forests on the Boone be managed for old growth. There's a lot of different um, reasons to manage forests in different ways. Uh, but it requires a lot of thought and intention to manage oil growth in a sustainable and smart way. And then the other question is, what does climate-informed forestry look like? There's a lot of assertions and statements thrown out there, but the science is complicated. It's still evolving. But it's something that we really need to be talking about. Um, and I'm hoping that, through presentations like this, folks can really just understand a lot of the sort of the foundational concepts, the ins and outs of these processes to be able to really, think about things that are complicated. I've talked about a lot of patterns and processes and trends, but the reality is that there's always variation. There's always differences from time to time, place to place. Um, it's complicated, but that complexity is what makes forests awesome. So I know that took a long time. I hope there's time for questions. Um, and we could put my camera back on. I asked them to turn it off so you didn't all look at my ear while I was looking at the other screen the whole time. Hey, all right. Whitney, do we have questions?
We do.
Cool.
All right. So the first question that we have from the chat is from Alan, and Alan's question is, why don't the logging companies use the left behind slash?
Markets. So in parts of the country where there's a lot of pulp and paper mills, there you end up in biomass facilities. You end up with more what's called whole tree harvesting, where there's a market for taking that material, chipping it, and utilizing it. But that's not necessarily a good thing because a significant amount of the nutrients in the trees are actually in the canopies and the smaller branches. And so leaving that material in the forest is actually really important in terms of nutrient cycling and not depleting the forest soil any more than you have to. It also can help reduce erosion. But there are also situations where there's just an excessive amount of slash on the ground. So, but that's ultimately why in Kentucky we really don't have an appreciable pulp industry.
Great. Thank you. Okay, the next question in the chat comes from Teresa, and I believe we're looking back to the video you showed of the landslide in the Redbird District, but her question is, how is that skid road not considered a road? It looks like a road to me. It's bigger and better than most of the roads that are maintained on the Boone.
Yeah. Um, how roads are defined is a kind of a national problem on Forest Service lands, and so we have what are considered system roads, which are numbered Forest Service roads that have to be meet certain engineering standards, and then we have what are called temporary roads. That they will often build for timber projects to reach timber that have to meet again certain engineering standards, and those will often be bulldozed and graveled. Um, and then we have skid trails and skid roads, which are not considered under the rules as actually roads. And so they really don't have to abide by any of those other rules or standards as they would with regular roads. They consider them as essentially ephemeral things on the landscape.
And
And
to
it's a
further that
problem
point,
nationally.
Jim, why is that such a problem? Can you elaborate on that?
It's a problem because a lot of ground is torn up. It can destabilize steep slopes. It can increase erosion. There are certain standards established by the state of Kentucky, or best forestry best management practices, which are largely established to protect water quality, and also minimum standards that the Forest Service has for things like water bars and reseeding these skid roads. But there's still a lot of impacts. In areas that aren't as steep, it's not necessarily that big of a deal. In really steep areas, in addition to exposed soil, they really increase or I would say decrease the stability of the slopes. So when we have a lot of areas that are landslide prone, like in Redbird, like in the Jellicos, those types of skid roads, they just destabilize those slopes and make it more likely that to have a landslide or other mass wasting. There are also pathways where we see a lot of invasive species establishment. That's another big problem with them.
Great. Thank you. Okay, the next question from the chat, back to the cliff line and riparian areas. Teresa asks, is Jim saying that the Forest Service is preserving cliff and riparian areas as old growth, that they shouldn't be cutting? Wait, hold on. Teresa, do you want to pop your audio on? And I think maybe I'm not reading that correctly.
Sure. So what I was asking is, Jim, are you saying that the Forest Service is preserving cliff and riparian areas and calling them old growth when they shouldn't be, and instead then they're cutting what is old growth that they shouldn't be?
So under the forest plan, two of the major prescription areas are the cliff line and the riparian areas. And those areas are defined based on the landform. So the cliff line is considered, I think, anything over 10 feet tall and I think 100 feet long. And segments are considered continuous if there's no more than 300 feet between them. So if they're smaller than that, it's not considered protected cliff line. Anything that big or bigger is considered protected cliff line, 100 feet above it and 200 feet below it to protect rare species and habitats. However, they give themselves wiggle room in the forest plan to cut in those areas if they decide they need to. So they don't do it a lot, but they can. So that's why I consider it generally compatible with old growth, because the type and amount of logging they can do, I don't think is so much that it would necessarily deter from long-term development of old growth characteristics. But it's only 300 feet, where it's 100 feet of generally very dry stunted forest at top and 200 feet below. So it's not a lot. And then the riparian area is somewhat similar, where it's defined by the floodplain and width from the stream. So it's usually about 200 feet wide corridors along the streams. And again, similar to the cliff line, they're not supposed to log much, but they are allowed to log in those areas. Smaller groups of trees are supposed to leave a certain number of trees, but they are allowed to cut in those areas. And I sort of include those. I'd say somewhat liberally is consistent with old growth at a landscape scale. So with those two areas, because we have so much, so many stream miles in the Boone and so many miles of cliff line, those narrow corridors add up to a lot of acreage. But again, it's these little ribbons across the landscape. And so those are areas where old and old growth trees are for the most part allowed to develop and exist, but they're not functional blocks of old growth forest. But the Forest Service uses the existence of those and their aggregate acreage, which is a lot, as a way to say, look, we have a ton of land that is essentially off limits to logging, and therefore we don't really need to plan for old growth in other places.
Okay. So I guess the next question is also mine. So does the Forest Service seem conducive to using your data to redefine what is considered old growth? And and preserving some of the tracks that are more contiguous that your data is showing, and maybe letting go of some of those cliff lines that actually aren't cliff lines. Is anybody seem interested in listening to what you're saying over there?
So this particular analysis is pretty new. It's something that I've been wanting to look at in more detail for a long time, and I started working on this analysis back in the fall, in preparation to give a talk to the Sierra Club. I was like, great opportunity to, spend some time digging in on this, and I was kind of surprised actually with what I came up with. So this isn't something that hasn't been presented to the Forest Service, and it still hasn't been fully flushed out. I do think what I would like to see, and I think is really, really important, is to put together a comprehensive plan that looks at these ideas and looks at, the geographic data, the ecological data we have, and puts together a reasonable proposal that would uh, allow for the development of a substantial amount of old growth across the Boone in a very smart way over time. And as much as I don't like most logging on the forest, we could develop a lot of old growth in the forest while still managing for younger forest habitats, disturbed forest habitats throughout the forest, in just a smart, deliberate way. I Over the last several years, the old growth that we have documented, that's high quality old growth, the Forest Service has been very obstinate and unwilling to accept information or data or even discuss it from us, which is incredibly unfortunate. And I'm not sure really how to get over that hump, to be quite honest.
Good question. Okay. Thank you, Teresa. Next question is from Judith. Judith is asking, can you say more about your personal view of old growth forest management compatibility, passive versus active management, for example?
Yeah, so there's many ways to think about old growth, even just within the suite of our forest community types here in Eastern Kentucky, just solely. And there's the original idea of old growth as the forest primeval, the virgin forest, the untouched forest, and it doesn't really exist. Um, we have areas that are considered reference sites, less disturbed, less human history. But the reality is that old growth is best thought of as a suite of structural compositional characteristics. Um, and instead of being places that are never disturbed, they're places that evolve through uh, time with the development and growth of trees getting old, and then the disturbance processes that are low to intermediate intensity disturbance processes affecting those forests over time at intervals that allow the majority of that canopy to become older and complex, but still disturbance is a component. And so when we think about old growth in that way, that where disturbance is an integral component of it, I think that there are ways in which some timber harvest can be compatible. I don't think it's necessarily compatible, and there's a lot of places that should just be left alone. But there are models, for example, if you have like a 60, 70, 80-year-old co-dominant forest, where you can do some very limited timber harvest that helps to create gaps, create down woody debris to sort of accelerate the development of complexity. So if you have a large landscape where you really don't have old growth, you don't have stands with gaps and large trees, you can have some silvicultural interventions that can emulate or accelerate some of those processes. Now, if you have forests that are 150, 200 years old, uh, timber harvesting those isn't going to help develop those things. Now, you can have situations, and I see this where we have forests that might be 150-year-old what I would consider secondary old growth. So forest that might have been logged in like 1880, 1890, but it's really developed a lot of the characteristics of old growth, but may have been affected by fire exclusion. And so we might see changes in the forest structure from what we think historically would have been the case. So in those cases, it might be that cutting some understory trees and felling a few trees might help sort of restore the function, for example, of a more open oak type forest. Um, and so I don't want to paint too broad of a brush, but I think it can be compatible. The other thing, and I think this is where my brain goes when thinking about large scale planning, has to do with scale. And so if you're dealing with a 100-acre forest, um, regenerating or cutting chunks that are, 5 or 10 acres, um, would be excessive, I think, in terms of meeting of developing that 100 acres into an old growth forest. But let's say you've got 1,000 acres that you're moving in an old growth direction. At that scale, you can have patches of disturbance that are larger, still within what would consider the natural range of variability and historic natural disturbance. So not 50 acres, which can happen with tornadoes, but not often. But you could have a handful of 5 acre, even 10 acre patches cut in a 1,000 acre area. And I think at that landscape scale, that could be considered compatible with that landscape developing into old growth. So as we increase the scale that we're looking at, I think there's more room for managing for disturbance in those areas for more variable habitat, understanding that broader uh, the broader forest is all trending towards that old growth complexity. Because at the landscape scale, patches of younger forest, disturbed forest, those are all part of that landscape complexity. And so we have to think about this at different scales as well.
Thank you. Okay. Next question is from Kayla. Kayla asks, is there anything lay people can do to help improve the odds of preserving these old growth forests? Do you want me to answer that?
Yeah.
Kayla, so the long and short of it is you're already partly doing that by being here tonight. Kentucky Heartwood believes that the first step to any sort of forest preservation and restoration begins with education. We can't possibly expect people to, stand up and get involved if there isn't a general understanding of what is going on public land. But the best thing that you can do is get involved with organizations like ours. If you have experience in other forests across the country, find out what organizations in the state are working for forest advocacy. And if that's not something you feel comfortable with, I'd be happy to direct you to some of these other organizations that are doing the work that we're doing. But specifically here in Kentucky, if you're on our mailing list that we send out once a month, that's how we're going to communicate with you about the main projects happening across the Boone, and we will give you exact directions and things that you can do to get involved and help protect some of these places. But the main thing is just getting involved. So I challenge you to take what you've learned tonight and tell one other person, and maybe even send them our website and tell them about the work that we're doing, because I think moving forward, it's going to be the people who are interested in protecting these spaces. We need to find the others and bring them into this space, because that's really going to be the mechanism that allows us to protect these places. Okay, next question. How does the 100-year floodplain data compare to the agency riparian mapping?
It really does not match up. So the agency data I have is from some Forest Service GIS data I got from them, uh, heck, probably 15 years ago now. Um, and it's just using much older geographic data. I mean, geographic information systems and data quality has just improved just immensely over, I mean, just even the last 5, 10 years. Um, And so the Forest Service data, both for the riparian and the cliff line, just was very general and broad and dramatically over estimated the areas that were would be covered under those definitions that they use in the forest plan. Uh, but with the newer data, we can really map it out. It's I'm not a GIS specialist. I know how to do some stuff. I've worked with it for a long time. Um, for somebody that was a really well trained, GIS specialist, you can do a really robust analysis. It's not that complex, really. Um, and so I think one of the big problems with it is that they're relying on some, we have a very outdated forest plan, and the science behind it's very outdated. And so that's part of the problem, is a very outdated forest plan. I do hope that this data that we've been developing can be used in the future to help make the case uh, for thinking about the planning quite a bit differently. The 100-year floodplain really isn't a lot of land. It's not a lot of area. And I don't know all the definitions and how it's defined. I forget the current term. It's not called 100-year floodplain anymore. This gets into like FEMA flood policy. And that's why there's actually a really robust data set that you can get online. And it has to do with FEMA data for flood planning and insurance adjustment and all that sort of stuff. So that's really where this newer data comes from and why it's pretty good. Um, so yeah, hopefully that answers it.
Great. Okay, last question here in the chat is from Mark. Mark asks, fundamentally, does the U.S. Forest Service want more old growth? If I understand your early slides, the U.S. Forest Service uses an old model that suggests no carbon sequestration value from old growth forests. So that would seem to incentivize harvest over preservation, right? If so, doesn't the U.S. Forest Service need a complete revision of how it values old growth forests? Any chance of that? Question mark.
That's
Great
been the big
question.
question the last couple of years. So the first part of that, no. The second part, yes. So a couple years ago, the Biden administration put out an executive order directing the Forest Service to do analysis and put together plans that would plan for protecting and managing for old growth across the national forest system. And so there's been a several year process going on that was sort of culminating in what was called the National Old Growth Amendment, or the NOGA. And what they came up with was a plan to uh, amend the forest plans for every national forest to include certain criteria that would protect existing old growth and have the Forest Service um, delineate areas to plan for the development of old growth, which sounds great. But the reality was that's not what it was going to do. Um, And then a couple weeks ago, the Forest Service dropped it. They were getting ready to publish the final environmental impact statement that would have fully analyzed the final proposal, but the Forest Service just dropped it after several years of a national process. Um, them dropping it completely is, to me, is not the disappointing part. The disappointing part is where it was really going in the details, because it sounded really good. There was a lot of good language that was really impressive and really refreshing, and gave a lot of hope initially. But the reality was, at least with the forests in our region and the Daniel Boone, it really wouldn't have changed anything. It would have left the problems with how they're identifying old growth still up to their really poor and subjective processes. It allowed loopholes for the forest supervisor to decide that even if they determine something is existing old growth, that it might just not be appropriate. Um, And in terms of the idea of planning for old growth of the landscape, the forest plan has designated old growth areas. It's only if I forget how many, somewhere I forget how many thousands of acres, but it's I think it's under 15,000 acres across the forest of designated old growth areas. But they were considering that as being sufficient, that they have these areas designated to manage for old growth. The reality is those designated old growth areas aren't old growth. When you do I've analyzed the stand age data from the Forest Service for those areas, and they trend slightly older than the forest on average, but they're really about the same. And a lot of the best old growth we find is not in those designated old growth areas. So it sounded really good. And if there was a really intent to apply it in good faith, it could have meant some really important and really cool stuff. But throughout the process, it became really clear that the Forest Service wasn't interested in it, especially in the east. The issues out west are different, and I'm not as well versed on the pluses and minuses of the proposals with respect to Western Forest. But with respect to the east, it was pretty bad, a pretty bad set of proposals that um, I think in the end might have actually done more harm than good, because it would have left an impression that things are protected that aren't, which is frankly the problem we usually have under Democratic administrations. A lot of people stop paying attention because they think things are protected and gonna be better, and they're really not. Um, so I in one sense I don't have a lot of hope. Uh, I find the Forest Service here to be very entrenched in some very regressive thinking on it. Um, at the same time, the science has really evolved. We know so much more. We have so many tools available to us. And over the last few years, the process over the National Old Growth Amendment has allowed um, a lot of dialogue and education, a lot of public education, and a lot of interesting new science to come about. So I think that the pieces in terms of the social pieces, the scientific pieces, they're all there to do something I think really fantastic. Um, but it's finding a way to actually make that happen. And again, the Forest Service likes to use a lot of straw man arguments against us. Um, and I think that's really unfair, because I think that there are ways to really protect and manage for a lot of old growth on our national forest system while still accepting the Forest Service's multiple use mandate and timber cutting for various uses, even if it's not what we want to see. Um, you can have both those things to some extent. And I think the hard work is figuring that out. But the Forest Service, I think, really doesn't want to try to figure that out, is my take, but it can be done.
Do we have any last minute questions? Okay, great. I don't see anything. Guys, thank you so much for being here. This is recorded. I will hopefully get it zipped and we'll pop it up on our website. If you would like a copy of this, just let me know. Shoot me an email. You can email where I sent the link. If you want to respond to that one, you can. If you'd like to send it to me personally, my email is whitney@kyheartwood.org. So you can really reach out to any of us. And I hope you'll have a great night. Thank you
Thanks
for
everybody
coming.
for joining. Appreciate it.
Um, excuse me,
Oh, yeah.
Jeff, are you willing to stay on for a few minutes for a couple other questions?
Sure. Yeah, I can stay on for a few more minutes.
Okay. I mean, I don't
Thank you.
mean to hold anybody up, but I have a couple questions for you.
Thank you, Jim. Very good.
Patty. Yeah, Judith, go. Yeah, what you got?
Well, I'd like a little more specifics about what the rub is with the current Forest Service. Like, I'm not sure. I haven't been involved in this in a long time, but my studies were old growth forests, and Blanton Woods was my study site. But so I guess I'm a little confused about um, if the Forest Service, the current Forest Service, U.S. Forest Service are they not hiring ecologists or botanists, that kind of thing? I mean, are
No.
we talking just pretty much wood management like it was in the 1960s or?
Yeah. I mean, it's mostly forestry techs going out, um, yeah, doing basic, basic forest inventory, with the emphasis on regen. A lot of this for me really got to be there was a certain point in time, maybe a decade ago, I thought we were moving in a more collaborative direction where we were having good dialogue. Things really went downhill with South Redbird, where we started finding multiple areas of really high quality, let's say sub-zero old growth. Like if you look at if you've been out to, Lily Cornet Woods, forests that high quality or higher quality. And we've documented them structurally, dendrochronology, demonstrated it, areas that are approved for cutting. And they say they're just younger and da da da.
Yeah.
And even without saying hey, don't cut anything, just this 20 acres, this 40 acres, this spot, they have just repeatedly said, no, we're not interested. You're wrong. Period. And we've got data, everything, and just hey, this chunk, this piece, and it's just, no, we're not talking to you about it. Period. And it's been frankly bizarre, because especially when you're looking at a project with thousands of acres of cutting, when you've got an aggregate of a couple hundred acres of high quality old growth, not even just hey, there's big trees, but two,
Right.
300-year-old high quality old growth, some of the best in the state. Them just saying that doesn't exist, you're wrong. We have two plots that a tech recorded 10 years ago. He recorded a tulip poplar and a black oak, so it's 70 years old, period. I mean, that's the kind of responses that we've been getting. And I've tried really hard to reach out to engage folks in the scientific community in Kentucky, especially folks who have been involved in old growth conservation, um, with the areas that are known. Um, and I cannot get anybody to say a damn thing. And
That's
it sucks because Lily Cornet Woods, I finally had to go there. I knew the data. I've worked with samples. I helped work on a paper. I knew that, I mean, all that, but I never actually hadn't gone out there until a couple of years ago. And I didn't quite know visually how it would compare with a lot of the stuff we're seeing in Redbird. And I finally got out there and I'm looking at it. I'm like, I think the stuff in Redbird's nicer. And they're about
yeah,
to cut it.
yeah,
And nobody gives a damn.
yeah.
And I've heard from folks that say, I know there's folks in the scientific community that are told specifically not to work with me and not to talk with me because I'm a problem.
How about the academic community? That's where I come out of. So I'm just curious. Do you have some allies there that can help you out with these things? I mean, it's not easy
No,
assessing old
I've
growth.
tried.
It's
I've
very tedious work.
I've reached out to lots of people.
Okay. Yeah.
And what's ironic to me is well, anyway, I'll leave it there. I have tried. I have really, really, really tried. And
Okay.
I can't get a single person to step outside of their comfort zone. And so you will have people celebrate Lily Cornet Woods and celebrate Blanton Forest at these special
Yeah.
places. And I'm like, there's some areas that are as good. We're about to lose them.
Right.
And I have people in those circles I talk to and they believe me and they trust me and they suspect that I'm right in my analysis and assessment, but crickets.
Well, we should keep talking because there's always a way legislatively, whatever. There's potential friends that we may not know yet. I
Yeah.
I don't mean to be Pollyanna about it, but I think you, we might be able to find more support.
Yeah, yeah, I would love to talk to you about it. I've reached out to others. I mean, we could drop names, we'd be talking about the same people. I've
Yeah.
reached out to certain people we know, to say, look, people are told not to talk to me. If this message came from you who believes me, they
Yeah.
might start to engage. And
Yeah.
then all I get is, oh, you should talk to those people. And it's
Okay.
I've been doing this for years. And, you know, so, yeah, like I said, I know, even though there's scientists who I work with on this from out of state, who I've worked with and trust me, and who are looked to from people in state, the people in state, a lot of them I know are told not to work with me.
Jim,
So
Zayara,
anyway,
Zayara
yeah.
dropped a point in the chat that I think would be relevant to Judith's question, but maybe talk a little bit about the timber targets that are being pushed from DC, and how that relates to the current Forest Service culture.
Yeah, so the Forest Service has denied for years that there are specific timber harvest targets. And about a year ago, some fantastic Freedom of Information Act work from the Southern Environmental Law Center uncovered that there are national targets for timber harvest volume that have been applied from Washington down to the Forest Service regions, down to the forests, down to the districts. And we've got a trove of data from the Daniel Boone National Forest that shows that over the last few years, they've been under mandates from DC to increase not the acres managed, but the volume harvested by over 400% over what they've done over the last 20, 25 years. And they've met those targets. And so and now what we're also finding, and SCLC has found, is that before these projects ever go to scoping or go to the public, the Forest Service internally has volume targets to meet, and that their performance is even evaluated based on meeting these volume targets. And they don't put that in the project description and in the purpose and need, and they say publicly that's not happening. But you, through FOIA, find out that is happening. So they're going into these big projects with these big volume numbers that they have to meet. And in order to meet that with the very limited staff that they have anymore, they have to put pretty much all the resources they have into their timber shop. They have to find areas where they can get a lot of timber out with as little analysis overhead as possible. And they need to go into areas where they can put together sales that purchasers will buy, because they're also competing with, the national forests represent only, the Boone is what, like 7-8% of Kentucky forest land. And so purchasers have to be really incentivized to want to deal with federal contracts and all the stuff they have to deal with. And so the Forest Service also has to put together really attractive sales. So we're going into areas where all the big white oaks marked. If there's big walnut, it's marked. It's got to be attractive to, the timber operators, the few of them that are buying this timber. And so when we found that out, it started to make more sense why the Forest Service wouldn't budge on just what we thought were just reasonable modifications that 5, 10 years ago we could have negotiated and worked out. So it even, yeah, so that makes it, that's this whole other, complicated thing. And it's been a frustration to me where, they started going up under the first Trump administration, but it went up dramatically over the last 4 years. And that really is kind of the primary motivating factor underlying these projects from the Forest Service end, which is why we need folks like from the scientific community to say, hey, wait a minute, there's some areas that maybe shouldn't be cut, and there's some other approaches, just, you know, cutting everything down to 10, 15 square feet of basal area, nuking it with herbicide and scattering acorns that they collected with some game hunting organizations. Like, that's it. Like, that's the cookie cutter plan across the Boone now.
Okay, that's the last of the questions in the chat. We are at time, so I will save this recording and get it posted. Thank you all so much for being here. Jim, great job. And we look forward to seeing you all in the future. Again, thank you for your time. This really is what matters, so thank you for being here.
Thanks, everybody. Have a good
Thank you.
night.